let's move to our next keynote profile, Dr. Amit Kukker, Associate Professor, Department of Computer Science and Engineering, SRM Institute of Science and Technology, Modinagar, Ghaziabad, UP, India. His expertise include artificial intelligence and large-scale distributed architectures, large-scale distributed platform architecture, generative AI-powered enterprise solution, scalable data architecture and intelligent system, AI-driven innovation in expertise, ecosystem, distributed computing, and system optimization. His today's topic is biomedical signal processing using AI techniques. So let's welcome Dr. Amit Kukker.
Thank you, ma'am. So, good evening to everyone. I am Dr. Amit Kukker from India. So, today my topic for discussion is biomedical signal processing using AI techniques. So, today I will discuss about the biomedical signal processing, its need, and for the algorithm I have used for the formulation of the problem. I have basically used biomedical signal processing based EMG signals I have used in my work for Fourier movement classifications. So in which I have used Hilbert-Hung transform, reinforcement learning, neural reinforcement learning. So first is the motivation why to choose a biomedical signal processing. As we know, we are using an traditional method which are suitable for simply calculation. But if we are talking about the EMG signal, EEG signal, or any other biomedical signal, so their behavior is non-linear and non-stationary because they are changing with the time. And for each individual, their values varying or changing. So, so if we are considering or assuming something, then we can't, reality can't be bent by the assumptions. So APLIA for adaptive data analysis, for this, we are using adaptive intelligent techniques. So the crux of the matter is that method that have good performance measure is for online prediction and timely diagnosis is considered best for biomedical cases. Sorry. Sorry, my screen is visible.
Yes, sir.
Yeah. Okay, thank you. So, biomedical signal is basically used for treating the application that are directly belongings to the human beings, or we are just taking engineers and doctors together and try to impart the gap between the engineering and medical areas and guiding the medical area person to use simulations, web-based online resources, and different engineering models. So it is the effort to combine the design and problem solving skill of the engineers with the medical science to solve and improve healthcare diagnosis and treatments. So, but what is basically adaptive intelligence techniques? It is a subpart of the artificial intelligence. It is the layer of AI and machine learning application that intersect the human judgment with the machine automation. So it has the capability of understand and adjust the analytical model input based on the training data, improve imperfections, and apply ethics to use and interpretation of the data. So adaptive analysis application for new category is adapting self-learning application. As I have discussed in the beginning, that I am using the reinforcement learning technique, which is a self-learning adaptive intelligent technique for four-arm movement classification. For this application, I will use these techniques. So basically, first I will describe the some few algorithm that we have used for our work. So first technique is Hilbert-Hung transform. Basically, this is a technique which is used for the decomposition purpose. So meaning of the decomposition is that, as I have discussed previously, the real-time signal like EEG, EMG signal, or any other biomedical signal, their characteristic is non-linear and non-stationary. As we know, the mathematical functions are generally applicable to the linear functions. So we have directly no mathematical function that can solve the nonlinear equations. For this purpose, so we will decompose the signal and try to convert the nonlinear signal into the linear signal. So for this purpose, I have used the empirical mode decomposition, which is the part of the Hilbert-Hong transform. So based on this, we are able to find energy, frequency, time representation of any signal. So this is the mathematics of the Hilbert transform, in which we are trying to decompose the signal and finding the real time frequency representation of any signal. So basically, just for better understanding, I will just show you how decomposition will work. Suppose these are the EMG signals. If you are looking on this signal, these are time varying signal. With the time, their value is changing, and for each individual, their value is changing at every moment. So we can't analyze. If you are seeing the first signal, first one, then we are saying that value is continuously changing. So if we want to find the feature for this, suppose we want to calculate mean value, we want to calculate standard deviation, average, or something like features, then this is not possible to analyze directly for this first input signal. So we are trying to decompose this signal based on the Hilbert-Hong transform. And if you are looking at the last signal, it is approximately seems to be the linear. So any mathematical function, suppose you want to calculate the mean value, you want to calculate variance, standard deviation, you can easily calculate for these signals. So this is our purpose. That's why we are using the Hilbert-Hong transform. So how it will work? It will take a cubic spline and it will put these cubic spline on the main signal and find the average value for each instance. Then we will calculate the average value and we will subtract each sample point from the original signal, and this process will continue till we will get the monotonic function, means we are not able to find the linear function. So it will take sometimes 7 to 8 iteration, and these iteration are called intrinsic mode functions. Next algorithm, which is the most important part of our research, is Q-learning, which is the part of reinforcement learning. It is a special type of the learning coming under the umbrella of the machine learning techniques, use reward and punishment scheme. So if you are going for the simple example, it suppose a person want to learn driving of a car, then he don't know how to take decision, how to accelerate, how to take apply the brake, or these what time he have to take the round, all these things. So based on their training, people can learn from here mistakes and start. If we are moving in the right direction, we will get the reward. If sometime we are doing some wrong thing, we will be punished. So same phenomena will be used in the reinforcement learning. So it will adaptive technique which will take action or which will adapt with requirement to the environment. So if we will talk about the mathematics, then there is a Q value which will work. There is a current state and we will take the reward value. Based on this, we will update our next state. If we are moving in the right direction, then we will get the positive reward and our value is going to be changed accordingly. And if we are taking the wrong path, then we will be punished and our value will be getting different. So based on this, we have tried to merge two techniques. One is reinforcement learning technique with the neural networks. As we know, artificial neural network, we have the number of hidden layers, we have input state, hidden layers. Then based on this, we are getting the output. So same technique we are applying here to identify forearm movements. So in the first attempt, we have used the EMG signal-based movement classification, in which first we have extract the signals from 20 different subjects, and then we will use the Hilbert-Hong transform and and decompose the signal first, and then based on decomposition, we have find the features like mean value, energy value, entropy value. These value we have calculated, and based on this we have applied artificial neural network techniques, in which we are taking the input metrics and output metrics, and based on this we are classify the signals. Some results I just for the methodology purpose. So first we are using the surface electrode that are directly placed on the human forearm. Then BioPack hunter system we have used for the feature extraction, And then we have used Hilbert's transform. Then based on ANN, we have classified. And in the second attempt, we have used neural reinforcement learning classifier for same classification task. So as previously shown, these are the EMG signal for a movement. We have taken 6 movements. One is hand close, then hand open, supination, pronation, flexion, and extension. These 6 movements we have used in our research. So these are the movements, and these are the BioPAC 100C system that are applied on a subject. For both hands, right and left hand, we have placed the similar way and calculate the signal. So this is the result of decomposition already discussed with you. And based on this, we have calculated the feature like mean, standard deviation, energy, entropy, maximum value, minimum value, and difference of maximum and minimum value. So as I mentioned, this will represent time, frequency, energy representation. So for all 3 domains, we have calculated all 7 values. So total 21 features are extracted for these. And for 10 subjects, I have shown the result here. So total 60 movements we have taken here. And based on this, we have designed input matrix of size 21 cross 60. And for target metric, as we know, we have 6 movement. On based of this, we have taken 6 into 60 metrics. So these are the result for a movement, and overall accuracy we have achieved for 6 classes is 97.5%. So these are the decomposition level, and we have performed the same experiment with different number of hidden layers. And these are the classification results for different 6 movements, and average accuracy we have achieved is approximately 97%. So I have tried to plot scatter plot for the different movements based on the parameter we have calculated, like amplitude and frequency mean, and between amplitude and phase mean. So based on this, we are able to find that our feature are moving in different patterns, so that can be easily classified by the classifier. So these are the conclusion of this experiment. So next we have used neural reinforcement learning classifier for elbow, finger, and hand movements. So similar 6 hand forearm movements we have used, but in this we have used 2 more experiment. One is the elbow angle prediction, and then typing finger classification task. So in elbow task, we have placed electrode on the forearm, and we have fixed the forearm, and we are varying the weight. Suppose we are taking first step 1 kg weight, then 2 kg, then 5 kg, and we are fixed the shoulder, and we are taking the angle 10 degree, 20 degree, 40 degree, 60 degree, and at different angles we have tried to classify these patterns. So based on this, we have calculated similar fashion. We have calculated 4 feature here: mean value, variance, zero crossing, and these parameter based we are try to calculate the accuracy of different movements. So these are the results. Approximately more than 95% we are getting the accuracy for different experiments. Similarly, for typing finger, we have chosen four typing keys like A, M, I, T. I have chosen here, and same procedure we have repeated for this and classified these 4 keys with the accuracy of 98.75%. Similar fashion, we have drawn a scatter plot for this, like previously we have shown. So if you are able to see here, then based on the absolute mean value for channel 1 and 2, means left hand and right hand finger, we are easily looking here that these features are separated by its own because their values are different. Because their feature value are different, based on this, we are easily able to identify the different keys. So in the last task, we have used forearm movement for 6 movements, and we have achieved the accuracy of around 97% average. So these experiment we have performed. Rather than this, we have performed this experiment with some other techniques, but I have mentioned here the 2 techniques due to the time constraint. So this is about topic. Anyone have any queries, please feel free to ask. This is all from my side. Thank you. Any queries, please?
Thank you so much,